we have y equals ax squared plus x plus c, excuse me, plus bx plus c. Okay, so we're going to start out with this quadratic, x squared plus 6x plus 5. So we've kind of already been doing this with the word problems, and we're just going to put it all together so you know exactly how to make the parabola, right? So first thing we have to decide is what's the best way to factor this quadratic. So we don't have a coefficient with x squared, so we're going to see, can we just do what times what equals 5, what plus what equals 6. If that's an option, then that would be our easiest method, right? If you can't do that, then you would see if the AC method works. If AC method doesn't work, then that's when you would use the quadratic formula. But luckily, we know that 1 times 5 equals 5, and 1 plus 5 equals 6. So we get to choose the easiest of all options, right, for when we're factoring. So then we would say, okay, well, x plus 1 times x plus 5 is what was multiplied to give us this quadratic. And then we set these equal to 0. X plus 1 equals 0. X plus 5 equals 0. X equals -1. X equals -5. So remember, these are our zeros. These are our roots. These are our x-intercepts, okay? So because I was able to factor this and find out my x values, I know that my x-intercepts are -1, 0 and -5, 0. So that tells me that my parabola is going to cross the x-axis at those two values. So that's great. We have the starting and stopping, but we don't know how high or how low the vertex is going to be, the peak or the dip. Okay. So this is when then we use that. How do we find the x value of our vertex? And we take that x value, put it back in to get the y value. So this should all be very familiar, right? So we've got x value of vertex. And this is where we use x equals opposite of b over 2a. Hopefully that was in the video on Monday. Right. So I'm going back up here for my a, b, and c. Right? A is 1, b is 6, c is 5. So opposite of 6 over 2 times 1 equals -3. So that's the x value of the vertex. Now, if you want to make sure you're on the right track, the vertex is going to be halfway between your x-intercepts. So you can just ask yourself, is -3 halfway between -1 and -5? Yes, so I know I did that correctly. If for some reason I got an x-intercept of 3, and I looked back up at my x-intercepts, I'd be like, all right, I did something wrong because that's not even within those two x-intercepts, right? So my x value is -3. Then I'm going to take this, and where am I going to put this to get my y value? Back up here, right? So I'm going to have y equals -3 squared plus 6 times -3 plus 5. Y equals 9 minus 18 plus 5. Y equals negative 4. So my vertex equals negative 3, negative 4. And then you're going to glue this paper right here. Make sure it's going the right way. There are numbers on here, right? So make sure that the positive numbers are at the top. Yeah, just a second. I have it frozen right now while I'm gluing. Yep. So then I'm going to graph this as best I can. I'm going to plot my x-intercepts. I'll zoom in on this for you. Negative 1, 0, negative 5, 0. If you want to cut out just like a section of this coordinate plane because it won't fit, that's fine. It's up to you. We draw an arrow, that's fine. Or like that, it's really going to be in this section here. So if you just want to cut out like a window from here, you can do that. And then my vertex is this negative 3, 4. Negative 3. And then I just connect these as best I can. Sorry, yes, it is negative 3, negative 4. So you're going to be required to understand what the axis of symmetry is. Based on everything you know about symmetry, who wants to tell me what you think the axis of symmetry would be for this parabola? What do you think, Hayden? So what do you think it would be for this?
It would be the vertex.
What part of the vertex? Maybe the x value, right? Because if I was to draw an axis of symmetry, it would be right here, right? Okay. So then my axis of symmetry is going to be x equals negative 3. Some people refer to it as AOS, axis of symmetry. So whatever your x value happens to be of your vertex, that's going to be your axis of symmetry. Okay, right? What would the mirror be? Another thing you're going to have to answer is, would this be considered a maximum or minimum? Why? Because it's a dip. Right? It dips down as opposed to peaking like I originally had drawn. That would be a maximum. So our vertex is the minimum of the parabola, right? If it was more like a mountain, our vertex would be a maximum of the parabola. Questions so far? It's all kind of coming together. So I'm using my notes from 2019 because in 2020 didn't have the students at this time of the year, and last year we didn't get to this because I had everybody every other day, so there were certain things we didn't get to. So this is my old school jam. We didn't use binders, we just used notebooks. What?
I said I like binders.
Well, I decided to transition to binders so that you could put like your tests and quizzes and hole punch things and practice pages. You have more of a complete algebra situation. Okay, let's go ahead and at least copy down example 2. Yes. You did ask me that yesterday. Yeah, before everybody goes to lunch.
Oh, okay.
Okay, so right away you should notice that this one's a little bit different. Doesn't look like the what times what plus what will work. We do have AC, but even before that, what should jump out at you as an option of the way we can start factoring this? Greatest common factor. Yeah. So what would my greatest common factor be here?
2.
We're actually going to take out -2. So that way then our x value is a positive coefficient. So if you have a negative a value, go ahead and take out a negative greatest common factor so that you don't have to deal with that negative the whole time. So then we're going to be left with y equals -2 times the quantity 4x squared minus 9. -2 times 4 will give me that -8. Negative times negative makes a positive. All right, we'll pick up